Good morning, good noon, or good evening. Welcome to the Learning Cafe, where the odds of serving you a bad Joe is zero. Hi, I'm Leanne, your friendly neighborhood barista. So, what can I get you today? Well, if you're into iced matcha lattes, bear in mind that that's the intensity of 5. Well, not the most intense of our drinks, but it can still pack a punch. Now, whilst you're enjoying your drink, let me tell you all about odds and chances. First off, let me tell you about sample space, event, and experiment. Okay. A sample space is a collection of or a set of possible outcomes of a random experiment. Sample space is represented using the symbol S. Event or the subset of possible outcomes of an experiment. Okay. A sample space will contain a number of outcomes that depend on the experiment, which is a process or procedure that can be repeated and that has a set of well-defined possible results or outcomes. The sample space for a random experiment is written within curly braces like this, and that there is a difference between the sample space and events. Okay, which is stated here in the first 2 points. Now, for an example, in rolling a die, we will get the sample space S as this, whereas the event can be written as 135, which represents the set of odd numbers, and 246, which represents the set of even numbers. These two are what you call subset. Okay. Lastly, the outcomes of an experiment are random and that the sample space becomes the universal set for some particular experiments. Now, let me tell you all about probabilities, or the function of events, where events can arise from one or more outcomes of an experiment or observation. They are numbers between 0 and 1 assigned to events. Mathematically, we can think of a probability as a function from a set of events that maps onto real numbers between 0 and 1. Different probabilities models can assign different probabilities to the same set of events. Now, we'll talk about different counting techniques. First, we have the multiplication rule, which explains the condition between two events. Basically, it denotes the intersection. For example, for events A and B, okay, with the sample space S. The intersection of A and B denotes the events in which both events A and event B have occurred. Hence, the intersection of A and B denotes the simultaneous occurrence of events A and B. This event can be written as A times B. Okay. For factorial rule, basically all you're going to do is to factor. For example, factor of 5 is 5 times 4 times 3 times 2 times 1 equals to 120, or 8 factorial, or which equals to 8 times 7 times 6, so on and so forth, giving us the answer of 40,320. Now, we will not delve that deep into these two rules, but we're going to delve deeper in the next two counting techniques. Okay, first, permutation rule, or a rule that you use when you count items when the order matters. And this is the formula. Whilst combination rule is used when the items or the arrangement of the items is not important, like this. Okay. Next, I'm going to discuss the two sample problems that uses permutations and combination rule in a further and a different supplemental video. Hope to see you there and talk to you soon.